Ever wonder how your favorite shopbot just gets you? Or how you can search for an image without even using the right keywords and it just pops up? Well, there's a secret sauce behind it all, a piece of tech that's completely changing the AI game. Today, we're going to pull back the curtain on vector databases. So let's just get right to the heart of the problem. If you type happy dog into a search bar, a regular system just looks for those two exact words, right? Simple. But what if what you really want is a picture of a joyful golden retriever playing in a park? The words are completely different, but the feeling, the meaning, it's the same. So how on earth do computers bridge that gap? That's the puzzle we're going to solve. All right, here's how we're going to break it all down. First up, we'll tackle the main challenge, finding meaning in just a sea of data. Then we'll get into the secret weapon, these things called vector embeddings. After that, we'll peek under the hood at the database engine itself, see how it's powering a revolution in the real world, and finally, look at how we can get even smarter with our searches. Let's do this. Okay, first things first, we really need to get our heads around the size of this problem. The digital world we live in is this wild, chaotic jungle of information, and for the longest time, computers have been completely lost in it. Just picture this for a second. On one side, you've got your perfectly organized spreadsheets, neat little rows and columns. That's a computer's dream. It's super easy to search, easy to filter. But then, on the other side, you have, everything else. All the text, all the images, the audio, the videos. It's this beautiful, chaotic mess. But to a computer, the actual meaning behind it all is basically invisible. So how do we crack this code? Well, the answer is something called a vector embedding. And you can think of these things as a kind of universal translator for all that messy, unstructured data. Seriously, this is where the magic really starts to happen. So what in the world is a vector embedding? Okay, imagine you could turn any piece of data into a unique numerical fingerprint. That's a vector embedding. But it's not just some random string of numbers, no way. This fingerprint actually captures the data's soul. And here's the really cool part. Things that have a similar meaning get a similar fingerprint. It's like a secret language for understanding the relationships between things. Let's make this a little more real. Think about fruits, okay? We could describe them with just 3 numbers. How sweet are they, how big are they, and what color are they? So an apple might be, say, an 8 for sweetness, a 5 for size, and a 7 for color. A banana, on the other hand, could be a 9, a 7, and a 4. All of a sudden, we're not just comparing words anymore. We're using math to compare the essence of the fruit. Vector embeddings do the exact same thing, just with hundreds, sometimes thousands of different dimensions to capture all those tiny, subtle details. So how does this actually work? Well, it's surprisingly straightforward. You take your data, a sentence, a picture, a song, whatever it is, and you feed it into a special AI model called an embedding model. This model is like a super smart analyst that just pores over all the features, the patterns, the context, and what comes out on the other side? A vector. A simple list of numbers that is basically the DNA of that data, translated into the universal language of math. Okay, so now we have these incredible numerical fingerprints for basically everything. But this creates a whole new problem. We don't just have a few, we have billions of them. How in the world do you build a library for all of this meaning? One that's not just organized, but searchable, in literally the blink of an eye. And believe me, that is a huge challenge. Think about it. Comparing a few fingerprints, that's easy. But trying to compare one single fingerprint to billions of others to find the closest match and do it in milliseconds? Yeah, that's a whole different ballgame. You're going to need a brand new kind of engine to pull that off. And this is really where we see the big split from what we're used to. You see, your classic old school database is all about finding exact matches. It's like walking into a library and looking for a book by its exact title. But a vector database, it's all about finding things that are similar. It's more like asking the librarian, hey, can you find me a book that feels like this other one I loved? To do that, it needs a totally different set of tools. So what's the secret? How are they so unbelievably fast? Well, it's a really clever trick. They make a tiny, almost unnoticeable trade-off. They sacrifice a little bit of perfect, 100% accuracy to gain a massive, incredible boost in speed. And it's a trade-off that is absolutely worth it, because most of the time, you don't need the one single perfect match. You just need a handful of really, really good matches, and you need them right now. The way they do this is with something called Approximate Nearest Neighbor search, or ANN. So instead of checking every single fingerprint in the entire library, which would take forever, ANN takes a really smart shortcut. It finds a match that's close enough. And you know what? For almost everything we need, close enough is perfect. That's the secret sauce that makes this lightning-fast semantic search a reality. All right, so we've covered the theory. Now for the fun stuff. What can we actually do with all this? Because the real-world applications are honestly pretty mind-blowing. And this stuff is already everywhere. Think about semantic search that understands what you mean, not just the words you type. Or recommendation engines that suggest the perfect movie because they actually get your taste. It's even used to find things like financial fraud by spotting transactions that just don't fit the normal pattern. But maybe the biggest game changer right now is something called Retrieval-Augmented Generation, or RAG for short. This is basically how we give our favorite AI assistants superpowers. Before an AI even tries to answer your question, it does a super fast search in a private library of facts. It grabs the most relevant documents, and then it uses that specific context to craft an answer that's not just smart, but actually true. It's like giving your AI a cheat sheet for the real world. And hey, don't just take my word for it. The folks over at Google Cloud point out that this is a huge deal. It's how we get rid of those bizarre AI hallucinations and start building tools that give us answers we can actually trust. It's all about making AI more reliable. But hold on, we're not done yet. There's another level to this. The final piece of the puzzle is all about combining the art of searching for meaning with the science of applying hard logic. This is where things get really intelligent. Just think about it for a second. Finding things that are similar is great, but in the real world, we almost always have strict rules, right? We've got budgets, we have non-negotiables, we have deal breakers. We need a way to combine that fuzzy, intuitive feeling of similarity with cold, hard facts. This is where hybrid search comes in, and it's awesome. Imagine you're looking for a house. You want a place with a certain vibe, a mid-century modern home with natural light. That's your vector search. But you also have a strict budget. You absolutely need 3 bedrooms, and it has to be in a top-rated school district. Those are your rules. A truly smart system has to be able to handle both of those things at the same time. Now, the old way of doing this was pretty clunky. You'd find 1,000 homes with the right vibe, and then you'd have to go back and check if any of them actually met your rules. It was slow, and even worse, you might find that none of them did. The new way is so much smarter. With something called inline filtering, the database is intelligent enough to search for the vibe and check your rules at the exact same time. So you only get the perfect results, and you get them incredibly fast. And that's the bottom line here. We don't have to choose between searching for meaning and searching for facts anymore. We get to have both. This powerful combination is unlocking a whole new generation of intelligent applications that really, truly get us. They understand what we want, and they understand the real-world constraints we live with. So where does this all go from here? We've seen how AI is learning to connect the dots, not just with keywords, but with meaning, and now with meaning and logic combined. As this tech gets even better, what's the next big, messy human problem that you think it's going to help us solve? The possibilities, they're pretty much endless.